I definitely don't want to give that up. But it's a real problem. It's like having an enormous, too much food put in front of you at a magnificent restaurant, and you want to eat it all in some sense, but then you know you better not, and you have to be selective about it. So.
What about sampling every?
Yeah, that's one possibility, right? But.
So what inspired you to?
But unfortunately, research certainly research in theoretical physics at the frontier in modern physics is difficult to do as a part-time job. It really requires blocks of time where you really concentrate, and that's what's been challenging more than anything. So I have kind of shaded into softer problems that I can deal with without that sort of concentration. But before long, I want to get back to mind going deep.
So what inspired you to write the book? How did you get into that?
Well, this book is actually mainly, although not entirely, a collection of things that I've written in the past. Columns for magazines and things that I was very proud of. But because they're in scattered places, they would get lost if they weren't sort of collected into a book. And so for a long time I wanted to collect them into a book, and the publisher approached me with that kind of project, and at the end I put a lot more effort into it. It wasn't just a matter of stapling things together. I went through all the pieces and rewrote them and added some new things and introductions, and then my wife supplied about 75 pages at the end of her blog. While we were getting the Nobel Prize and romping around the world that first few months, she kept up her blog. Every night she would write down a diary, sort of a public diary of what we were doing, and it's really unique, I think, and a unique account of what happens. They actually linked to it at the Nobel Foundation website, so it's the official record. But so it's a book. I think it's written at different levels, and there is a certain amount of repetition because the core of it is this collection of things that were written before. But there's the new stuff, and I hope because it's written at different levels, everyone can find something to enjoy in it. But some of the things are very, very challenging, I think, even to people who have degrees in physics. A couple of the articles are real research articles, but most of it is accessible, and some of it is very accessible. There are poems, there's advice to students, and
Dr. Wilson, speaking of different levels, I was wondering if you wouldn't mind describing, like in layman's terms, the theory that got you the Nobel Prize.
Well, sure, that's easy. There are four fundamental forces in nature. Well, it's convenient to say that there are four fundamental forces, and it's close to the truth. So there's gravity, which we've known about for a long time, and for which Newton supplied a very elegant law back in the 1600s, and then Einstein produced an even more elegant theory, general relativity, in 1915. There's electromagnetism, which was the triumph of the 19th century, and brought together by Maxwell and Maxwell's equations, which is around 1860, and then refined, and so there's a wonderful theory of electromagnetism, which then, in conjunction with quantum mechanics, also became the theory of how atoms work, and it's the basis of our physical understanding of chemistry and so forth. Then, in the early part of the 20th century, when people started to figure out what atoms were all about, they learned that atoms consisted of a big cloud of electrons around tiny nuclei. And it wasn't understood what the nuclei were or what held them together. And in the course of studying the nuclei, it became clear there were at least two new forces that had to be introduced to account for the behavior of nuclei. So one is the strong force, which is responsible for holding it together, basically. The electric force is repulsive, right, because it's all the positive charge in the atom is in the nucleus. And the gravitational force is much, much, much too weak to hold it together, so it had to be a new force. It got called the strong force. It's the strongest in nature. And then there's something called the weak force, which is a little more obscure, but has to do with the interactions that cause neutrons to change into protons or protons to change into neutrons in radioactive decays of various sorts. So there was no mathematical description of these forces worthy of standing beside Newton's laws or general relativity or Maxwell's equations well into the 20th century. And it was a big frontier of gathering information experimentally and thinking about it. And then in 1973, we figured out what the equations for the strong force should be. Assembling various experimental clues, it turned out if you assembled them in the right way, they were very powerful and pointed to a unique theory. And so we just made that argument, and then were able to figure out enough about the theory that we could propose ways of testing it. And that's what's now known as quantum chromodynamics, or QCD. And is universally accepted as the theory of the strong interaction. So calculations were correct and difficult, so we didn't have didn't have any problem getting it published. It's just
how one can be a good researcher.
What?
How one can be a good researcher to you?
Well, the main thing is to be curious and work. And
we have many screws to tighten the lab.
What's that?
We have many screws to tighten the lab. We need to find the right one.
Yes. Well, so yeah, you have to think about it, keep thinking, I guess, and be curious. And you know what, I don't know if this is a good answer or even whether I should say it at all, but in my experience, when I have to sort of force myself to work, say, gee, this is really what you ought to be doing, and that's not when I do my best work. I do my best work when it's fun, right? So I think it's important to keep looking for things until you find something that's really fun and you just like to do it, right? You know, you'd rather do that than watch television or something. You know? That's what works.